Hello everybody, in this lesson we're going to talk about the roots, zeros, and x-intercepts, basically all meaning the same thing. It's just different terminology. So here on the first one we're going to find the x-intercepts of f of x equals x plus 9, x minus 7. Now if we FOILed that out, we would have a quadratic trinomial. Finding the x-intercepts is what you get. If we were to graph it, where would it cross the x-axis? Algebraically, we can do this by setting it equal to 0. By setting this equal to 0, we essentially make two equations. What two values of x would make the entire equation equal to 0? And due to the zero product property, either of these two, x plus 9 equals 0 and x minus 7 equals 0, would do what we intend. Solving this for x, we have x equals negative 9. Solving this for x, the other one, we have x equals 7. Alright, and x-intercepts generally listed as coordinate points. X-intercepts, negative 9, comma 0. There's always a 0 for the y-coordinate of an x-intercept. This x-intercept would be 7, comma 0. And those are the two x-intercepts of the function f of x equals x plus 9 times x minus 7. Let's have a look at number 2 here. This time find the x-intercepts of 2x squared plus 7x minus 4. Alright, once again, finding the x-intercepts. I don't see it, but essentially we need to set it equal to 0. Alright, and we're going to use the AC method of factoring. Notice our A term is 2, our B is 7, our C is negative 4. First we're going to find A times C, which is 2 times negative 4, which is negative 8. The question we need to ask ourselves, what factors of negative 8 add up to positive 7? Alright, we think about how do we get negative 8, factors of negative 8. There are lots of ways to do that. But the two numbers that would work are a positive 8 and a minus 1. X plus 8, x minus 1. Alright, this is the first phase of that AC method of factoring. Now we go back to the A term, which is 2, and we divide each of these numbers by 2. And if they divide, great. That'll be part of our answer to help us find our final ultimate answer. If it doesn't divide, stick that 2 in front of the x. Alright, so remember we still have our function here. F of x equals now x plus 4, 2x minus 1, we're equal to 0. Alright, in the same situation on the previous example, we have now two equations, two expressions that we set equal to 0. X plus 4 equals 0, 2x minus 1 equals 0. We solve each of those mini equations for x. On the first one, x is equal to negative 4. On the second one, we're going to add 1 to both sides, divide by 2. X equals 1/2. First one is x equal negative 4, and x equals 1/2. Now if we were to put these as coordinate points, as x-intercepts technically are, coordinates would be negative 4, comma 0, and 1/2, comma 0. Let's look at one more here. Find the zeros. This question is listed as find the zeros of 2x squared plus 3x minus 20. Alright. You may look at this and go, well, can we take out a GCF? Maybe factor out a 2? Well, we can factor out a 2 from 2 and 20, but not 3. So once again, let's use that AC method of factoring, where we have A times C, which is 2 times negative 20, negative 40. Question we need to ask, what factors of negative 40 sum to positive 3? Alright, we will set that up here. Think of all the factors of negative 40. We got 2 and 10, 8 and 5, 40 and 1, 20 and 2. The one that's going to work to satisfy this scenario is an 8 and a 5. And not just 8 and 5, we need the right signs on that. Positive 8 and negative 5 as opposed to negative 8 and positive 5. If we add positive 8 and negative 5 together, we get positive 3. So this is going to work. We go back to our A term, 2, and each of these numbers get divided by it. If it divides, great, wonderful. That helps us to our ultimate goal. If it doesn't divide, we just stick the number out in front. Now, since we're finding the zeros, remember, zeros, x-intercepts, roots, same thing. We set equal to 0. We're going to say x plus 4 equal to 0. That solves to get x equals negative 4. And then we're also going to set 2x minus 5 equal to 0. Add 5 to both sides, divide by 2. Well, the other x is 5/2. Alright, now technically you could call these two numbers the roots. Roots are defined as the values of x for which a polynomial or an expression, in this case a quadratic, a trinomial, makes the equation equal to 0. So either of these two values make this equal to 0. So we could answer it just like this. We don't necessarily have to state them as points and x-intercepts, but these are roots, also known as zeros. If we were to graph this quadratic, it would intersect the x-axis at these two x values. Okay, thanks for watching. Hope this helped.